So in this video, I'm going to discuss with you the definition of concurrence. Okay. So here what it is defined, let M belong to set with M different from 0 and if A comma B belong to C such that M divides A minus B, such that M divides A minus B, then we call A is concurrent, congruent, concurrent to B. And we write A concurrent to B modulo M. Here also we write such that A minus B, then we call A is concurrent to B modulo M. Okay, so this is a definition of concurrence. That is, if you are given an integer M different from 0 and if A, B belong to set such that M divides A minus B, M divides A minus B, using the definition of divisibility, it implies that A minus B can be expressed as a multiple of M for some K belong to C. So for example, 7 is concurrent to 2 modulo 5. Why? Because by taking A is equal to 7, B is equal to 2 and M is equal to 5, what does it mean? This example, it shows that it implies that 5 divides the difference of these two, that is 7 minus 2, which is equal to 5. So 5 divide 5. And if you take another example, say A is equal to 6, 6 is concurrent to 3 mod 3. M is equal to 3, A is equal to 6 and B is equal to 3. Why? Because here this 3 divides the difference of these two, that is 6 minus 3, which is equal to 3. So 3 divide 3. But 6 is not concurrent to 3 mod 2 if you take M is equal to 2. Why? Because 6 minus 3 is equal to 3. But this implies that 2, that is M, does not divide 3. Or we can say that 2 here does not divide the difference of 6 minus 3, which is equal to 3. So this shows that M is equal to, that is 2 here is 6 is not concurrent to 3 mod 2. So now we come to some of the basic properties I'm going to discuss. For example, the first one, basic properties. Just like in the case of definition of divisibility, first basic properties, it states like this: if A is concurrent to B mod M, then we know that this concurrence satisfies this, it is an equivalence relation. Okay, equivalence relation means it is reflexive, transitive and symmetric. Why? Because A is concurrent to B mod M. Here we have A is always concurrent to A mod M. Why? Because M here implies that M divides A minus A, which is equal to 0. M always divide 0. And number 2, so this shows that this concurrence relation is reflexive. Number 2 is that if A is concurrent to B mod M, it always implies that B is concurrent to A mod M. Symmetric. Why? Because A concurrent to B mod M implies that M divides A minus B, which implies that M divides also B minus A by taking minus outside. So therefore, if M divides A minus B, it also divides B minus A. So this implies that B is concurrent to A mod M. And moreover, it is transitive. Why? Because if A is concurrent to B mod M, and B is concurrent to C mod M, what we need to show is that A is concurrent to C mod M. By this relation, M divides A minus B implies that, okay, M divides A minus B, and by this relation, it implies that M divides B minus C. So consider now this one relation A minus C. A minus C here can be expressed as A minus B plus B minus C. You add and subtract by B. So what does we have here? M divides A minus B. It implies that A minus B is equal to MK1 for some K belong to C, the set of integers. And from here, M divides B minus C. It implies that B minus C is equal to M into K2 for some K1, K2 belong to the set of integers. So now you replace this A minus B by MK1 and this B minus C by MK2. So as you can see, M is common, MK1 plus K2. K1 and K2, they are integers. Sum of an integer is again an integer. So this shows that A minus C is a multiple of M, which implies that M divides A minus C. If M divides A minus C by definition of divisibility, then we say that A is concurrent, implies that A is concurrent to C mod M. So hence, this concurrence relation is an equivalence relation because it is reflexive, symmetric and transitive. And then some more basic properties. If number 2, if A is concurrent to B mod M, then AC is concurrent to BC mod M. How? A is by this A concurrent to B mod M implies that M divides A minus B. So this implies that A minus B is equal to M into K for some K. So now you multiply both sides by C. So this implies that A minus B into C is equal to MK into C, where C is an integer. So this implies that AC minus BC is equal to M into KC. K is an integer, C is an integer, so this whole thing will be an integer. So this implies that M divides AC minus BC, or we can say that AC is concurrent to BC mod M. Next, number 3, if A is concurrent to B mod M and C is concurrent to D mod M, then A plus or minus C will be concurrent to B plus or minus D mod M, and number 2, AC will be concurrent to BD mod M. So number 1, what is given here is that A is concurrent to B mod M implies that M divides A minus B. So this implies that A minus B is equal to MK1 for some K1 belong to C. So name it as equation 1. Now C is concurrent to D mod M implies that M divides C minus D implies that C minus D is equal to MK, to name it as equation 2 for K1, K2 belong to C. So this implies that what we have to show is that A plus here, A plus C. So from 1 we have what you just adding 1 plus 2. Okay, we have A minus B plus C minus D is equal to mk1 plus mk2. Or you can write A plus C is equal to B plus D. Bring this B and D to the right hand side, plus m times of k1 plus k2. K1 plus k2 is an integer, so their sum is again an integer. So, or you can write here A plus C minus, you can write this, no need to transfer this, AC minus B plus D is equal to m times of k1 plus k2. So this shows that this whole thing from the left hand side is a multiple of m, which means that m divides A plus C minus B plus D, the difference of this two. Or we can say that A plus C is concurrent to B plus D mod M. So this is proof. Similarly, if instead of adding you subtract it, you will get A minus C will be concurrent to B minus D. And the last one is, if A is concurrent to B mod M, it implies that A minus B is equal to mk for some k belong to C, and C concurrent to D mod M implies that C minus D will be equal to mk2. Okay, this is k1 for k2 belong to C. So what we have to show is that AC minus BD. So what you have to do here is consider this relation, consider AC minus BD. This can be written as AC minus AD plus AD, add and subtract by AD in this, and then minus BD. So from this two you take A common, C minus D, and from here you take D common, A minus B into D. So this is equal to A. What is C minus D? From here, C minus D, it is equal to mk2. And what is A minus B from this relation? It is D into mk1. So this, as you can see here, m is common. So m into ak2 plus dk1. But these are all integers. A, D and k1, k2, they are integers. So their sum also will belong to set of integers. So from here this implies that AC minus, this implies that M divides AC minus BD. Or we can say that if M divides AC minus BD, the difference of these two, then what does it mean? AC is concurrent to BD modulo M. So these are some of the basic properties of concurrence. By concurrence we mean that if you have integers a, b belong to set and with m different from 0, then if such that m divides the difference of these two, then we call A is concurrent to B modulo M, and symbolically we write A is concurrent to B mod M. And some of the example also I have discussed. So I hope it is clear to you what is meant by concurrence and divisibility. They are related, okay, because if A, B is concurrent to B, A concurrent to B mod M means that M is divisible by A minus B.